Hi, my name is Vincent, and for my final project, I made a heart rate monitor using a pulse sensor. So, the goal of my project is to read a person's heart rate. My project will count the number of beats the heart makes in a span of 60 seconds. I will also output the raw pulse and beats per minute onto the UART terminal, and after recording all that information, I will then transmit that same information um, into a host using the HC06 Bluetooth module. And at the time of this recording, I have successfully read a person's heart rate, and I successfully transmitted all of the data mentioned above to the host via Bluetooth. And so this is my schematics that I came up with. These two are the schematics that came from Fritzing. And as you can see here, I used a LM34 temperature sensor instead of a pulse sensor because Fritzing did not have the pulse sensor symbol block. So I just used this LM34 sensor because it had the same number of um, wires going into it. So we have the 5 volts VCC, the signal, and the ground. I also attached an LED to pin B3. So every single time that I record a pulse, the LED will blink to indicate that a valid pulse has been read. And then over here we have the HC05 Bluetooth module. I used the HC05 Bluetooth module for this schematic because Fritzing also did not have the HC06, but it's pretty much the same thing. And then this is the breadboard schematic as a whole. So as we can see, we have the ATmega 328P on the breadboard along with the LED, the Bluetooth module, and the quote-unquote pulse sensor. And then this is what it looked like after I implemented it onto my X Mini board. And then for design stages, so the components that I used was the AVR ATmega 328P Explained Mini. I decided to use that because it was a lot easier to utilize the data visualizer. I used the pulse sensor, the HC06 serial Bluetooth brick, and an LED block. I only used one LED in that block, by the way. And then as far as interfaces, I use the ADC to read values from the pulse sensor and UART to interface with the Bluetooth module. And then for the host, I use my laptop because I did not have a Android phone that I could use to transmit the data to. So I just used my laptop with Bluetooth. And code development. So as far as initialization goes, I only had to initialize ADC and USART. And then for data collection, I set up a timer to check for a pulse for every second. And then once a pulse is read, it is checked. And by checked, I mean comparing that value that was read from the pulse sensor to a threshold value, which will verify if a pulse is legit, or if it was just caused by noise, or if there was just a loose connection anywhere, or if the pulse sensor was just loose around my finger. And then once the pulse is verified, the beat counter is then incremented, and then the LED will blink, signifying that a valid pulse has been read. And then I do this for 60 seconds. So, and after 60 seconds, you will see the beats per minute outputted to the UART terminal. And then after that, I will reset the timers, and then reset the time variable. And the time variable is a variable that holds the value 60, and that represents 60 seconds, which equates to 1 minute. And then I will also reset the beats per minute so I could record a new set of set of beats per minute. And then after that, I will just repeat the process and pull for another um, pulse. And then for networking and visualization, for this we had to pair the HC06 Bluetooth module with the host Bluetooth connection. The name of the Bluetooth module for the HC06 is ITEAD, ITEAD, and the default pin code for this device is 1234. And so the way I simulated everything was by opening two windows of Atmel Studio. One window had code and one window was empty. And then I opened the data visualizer on the code window and connected to the MEDBG in the serial port control panel. And then on the other window, the empty window, I opened the data visualizer and connected to the standard serial over Bluetooth link into the serial port control panel. And then lastly, I created graphs for each data visualizers and I pressed connect on both of them. And then this will then pull the code window will then pull for a pulse check and output it to the UART terminal, and all of this information as well as the graph will then be transmitted to the host via Bluetooth. And then this is just the flowchart of my code. So I initialize ADC and USAR, set up the timer and pull for a pulse, read and check the pulse value, compare it to the threshold, and the threshold is a value anywhere between 0 to 1024. And by lowering the threshold value, you make the pulse sensor more sensitive, and increasing the threshold value will make it less sensitive. And then if valid, increment the beats per minute variable, print the raw pulse and BPM, and the BPM will only be printed after 1 minute, and then reset the timer, and then repeat and pull for the next set of beats or no, pulses. And then the last slide is just the demo snapshot video, and then you have to provide links here, but I haven't uploaded the video yet, so I will be doing that right after this.